All right, in the previous lesson, we looked at what stoichiometry is, a mole-mole calculation, which is a one step that's in every single stoic problem. And then we went from moles of one substance to grams of another, which is two steps. In this lesson, you're going to do two steps again, and then a three-step, which is the maximum. So if you don't have a periodic table and calculator, I would pause and get that. All right, type 3, we're going to go from grams of one substance to moles of another. So in our mole map, we are going to start here, go to moles, and then we're going to go to moles of the other substance using our balanced equation, our mole-mole ratio. So if we are looking at what we have here, we have carbon dioxide is what we're starting out with, and we wanted to solve for moles of oxygen. So we are going to start with carbon dioxide, which is right here, and we're going to this one. All right, so grams of carbon dioxide. Now I can't go straight from grams of one substance to moles of another, so I have to convert this first. So we're going to start with a molar mass conversion. So we're going to divide by the molar mass. If we were to calculate carbon dioxide's molar mass, it's 44.01. All right, one carbon, two oxygens. That is going to cancel out. Now we're in moles of CO2. So this is a two-step problem. Now we're going to do our mole-mole ratio. We have 6 moles of carbon dioxide. That will go on the bottom to get rid of it. And we are going to go to 6 moles of oxygen. Now I get that that is not going to change it mathematically, but just showing you the setup here. So in my calculator, I'm going to just hit 50.78 divided by 44.01. So 50.78 divided by 44.01. And that gives me 1.154. Now I'm going to go by the number of sig figs in my given moles of oxygen. Notice I write everything out because it is easy to confuse things. All right, in theory, that is how much oxygen I should create from that mass, that starting mass of carbon dioxide. The next one is exactly the same, different equation, but same process. So pause this and see if you can do this on your own, and then you can come back and check. All right, this time we're starting out with hydrogen, and we are going to ammonia, which is this. Okay, so nitrogen not involved. We are going to start out with 50 grams of hydrogen, and we want to go to moles of ammonia. Well, we can't go straight there, so we have to do our molar mass conversion first. Hydrogen weighs 1.01. If we double that, we get about 2.02 grams of hydrogen. That's your molar mass on the bottom. Oops. Right, that will cancel out. Now we're in moles of hydrogen. We have 3 moles of hydrogen in our balanced equation, and we have 2 moles of ammonia that will go on top. So we're going to take 50 times 2, which is 100, and then I'm just going to consolidate this a little bit. So 100 divided by 6.06. So 16.5 moles of ammonia. So in theory, that's how much you should produce from that mass of hydrogen. All right, same thing. You can try this one out. Come back and see what the answer is. All right, in this case, we're starting out with potassium sulfate, and we are going, so this is our potassium sulfate, and we are going to moles of potassium chloride. So we're going to start out with 32.5 grams of potassium sulfate. So 39, we got to get the molar mass first. 39.1 times 2 plus 32.06. I'm just adding the molar masses up, and then 64, that's 4 times 16. So 174.26 goes on the bottom. 1 mole of K2SO4 goes on the top. That is going to cancel out. Then we're going from potassium sulfate to potassium chloride. 3 moles of K2SO4 on the bottom. 6 moles of KCl are on top. Now we need to figure out the molar mass since we're going, oh, I'm just kidding. I went too far almost. So we are done actually because we want moles. Moles of potassium chloride. So 32.5 times 6, and then we're going to divide by those. So 32.5 times 6 divided by 174.26 divided by 3. So we get 0.373. 0.373 moles of KCl. That is a decimal point. So that's how much you should create from that amount of potassium sulfate. All right, this is the final one. This is a 3-step. So we are going to go from grams to moles to grams. So the whole thing. All right, this time we want to know 45 grams of oxygen. That's our given. We want to know grams of water. So O2 and water is what we're dealing with. All right, so we're going to start with a molar mass conversion. Then we're going to do a mole-mole ratio from the equation. Then we're going to end with the molar mass conversion. So 45.00 grams of oxygen. All right, get rid of the grams by dividing by the molar mass. 32 grams, 16 times 2 from your periodic table. That will cancel out. We have 5 moles of oxygen per 6 moles of water. I am getting that from this. Always have to use that. And then to go from moles of water to grams of water, find your molar mass of water. Okay, so we're going to take 45 times 6 times 18.02, and then we're going to divide by this. All right, so 45 times 6 times 18.02 divided by 32 divided by 5. So we get 30.41 grams of water. So in theory, you should produce 30.41 grams of water if you start out with 45 grams of oxygen. All right, try this one out. 3 steps. In this case, we're going from ammonia to nitrogen. All right, so 30 grams of ammonia. 17.04 grams is the molar mass. I'm going to be lazy. I'm going to write these out. All right. Then we do our molar mass or mole-mole ratio. So we are going to do 2 moles of ammonia on the bottom, 1 mole of N2 on top. That will get rid of my moles of ammonia, and we're going to get to N2. Then we're going to pivot to grams of N2. So 2 times 14.01 is 28.02. And that will cancel out. So now 30 times 28.02 divided by this. So in our calculator, 30 times 28.02 divided by 17.04 divided by 2 gives us 24.7 grams of nitrogen. And that's how much we should make in theory. I'm sorry, that's not how much we should make. We should have. This is a reactant. So this is how much we should have to start out with to create 30 grams of ammonia. All right, last one. See if you can pause this one before copying down the work. All right, in this one, we're starting with 5 grams of aluminum chloride, which is this stuff, and we are going to grams of potassium chloride, which is that stuff. So again, same process. We're going to go start with our grams, which is 5 grams of aluminum chloride. All right, we have to get rid of our grams and get it into moles. So aluminum weighs 26.98. You can look at your periodic table for this. But 26.98 and plus there's 3 times 35.45, which is each chlorine. So 133.33 is going to go on the bottom. Now we do our mole-mole ratio, as always. There are 2 moles of ACl3 on the bottom, and there are 6 moles of potassium chloride on top. That will cancel out. Now we will do our molar mass of potassium chloride. That is 39.1 plus 35.45. 74.55 grams. And that's KCl. Okay. Now in my calculator, that's 5. My handwriting's sloppy. 5 times 6 times, what was the other? 74.55 divided by 133.33 divided by 2. So we get 8.4 grams of potassium chloride. So in theory, I should create 8.4 grams of potassium chloride should I start with 5 grams of aluminum chloride.